removal of stains from clothes is a general problem in fabric washing. Detergents have to be formulated in such a way that several complex physico-chemical mechanisms assist in the removal of these stains. In order to recognize and understand these mechanisms, the removal of soil from fabrics has been studied by video microscopy. A wash liquid flows through the system under various controlled conditions. The processes of soil loosening and removal are shown at 1000 magnification. We will show you some of these processes in more detail, concentrating on fatty soil and protein soil of biological origin. Fatty soil adheres strongly to the fiber of a textile. During the wash, surface active agents present in the formulation interact with the soil, reduce the adhesion, and remove oil droplets from fibers by a so-called roll-up action. Through the microscope, we can see that fatty soil adheres strongly to the fiber surface and also thus retains other types of soil. On this cotton fiber, the fatty soil is easily removed from the fiber surface. However, the soil between the fibers is difficult to rinse out. The rolling up of the fatty soil can best be observed in model experiments. A droplet of vegetable oil has been applied to polyester fiber or film. Without detergent, the droplet is hard to remove. However, after addition of some detergent, the droplet is rolled up and easily removed from the fiber. Similar mechanisms can be observed when skin fat has been applied to the fiber and film. Under ideal washing conditions, fatty acids are rapidly extracted from the fat droplets. The interfacial tension between oil and water is very low during this process, and the fat is removed easily. We call this the entrainment effect. Fatty soil, such as used motor oil and edible fats, is difficult to remove in the main wash. The removal is, however, facilitated when the soiled textile is pre-treated with a liquid detergent and then washed and rinsed. After rubbing in, a specific interaction between the fatty soil and pre-treating liquid detergent takes place. This interaction is decisive for the removal of the soil during washing. The fatty soil and liquid detergent are then diluted, for instance, according to the line A, B, C. In the B area, the interfacial tension between oil and water is very low, and the fatty soil is easily removed. So, pre-treated soil of used motor oil is hardly removed from the fiber when the liquid detergent-oil ratio is initially 1 to 10. Large drops are formed. However, when during pre-treatment this ratio is changed to 1 to 1 and the system is rinsed, the removal is easy and complete. The oil is emulsified in very small droplets, which can easily be rinsed out. The same can be observed with the edible fat trioleate. The favorable effect of pre-treatment can also be achieved in the main wash by using non-ionics as liquid detergent. Depending on the ionic strength of the wash liquor, non-ionics precipitate on the textile at a specific temperature, for instance at 36 and 75 degrees centigrade. We call these temperatures cloud points. When the temperature drops below the cloud point, the non-ionic dissolves again in the water and the oil is removed from the textile. So, during heating, the non-ionic precipitates on the fibre. During cooling or rinsing, the non-ionic again dissolves in the water and the oil is removed. The hardness of the wash liquid plays an important role in the washing process. When soft water is replaced by hard water, the fatty acids, together with the calcium salt present in the water, form an insoluble soap. This soap precipitates on the surface of the oil droplet, forming a sort of skin. This makes the fatty soil more difficult to remove. However, when we reduce the hardness by a so-called builder, the soaps are dispersed in the wash liquid and can easily be removed. Let's now look at the removal of biological soils, like egg yolk. egg yolk is not removed when only water with a surfactant is used during washing. When we add enzymes to the wash liquid, the egg yolk is gradually degraded. Studies, as shown in this video, contribute to a better scientific understanding of the mechanism of soil removal and thus to the development of new detergent products.